11.5, Day 2, Measures of Central Tendency and Variation. Please write down the essential question. How do I find variance and standard deviation? The data sets 19, 20, 21, and 0, 20, and 40 have the same mean and median, but the sets are very different. The way that data are spread out from the mean or median is important in the study of statistics. As you can see, the median is 20. If we added all these three together and divided by 3, and added all these three together and divided by 3, what would happen is we would get a mean of 20. But now we're talking about how spread out they are from the mean or median. That's a different story. That would be the variance and standard deviation. A measure of variation is a value that describes the spread of a data set. The most commonly used measures of variation are, and I'm going to highlight these, range, interquartile range, variance, and standard deviation. Variance is the average of the square differences from the mean. And the symbol for variance looks like this. Sigma squared. And this little tail in the end didn't mean for that to happen. Let's try that again. Sigma squared. Standard deviation then is just sigma because it's a square root of variance. Range is going to be your largest number in your data set minus your smallest number in your data set. That is range. Whereas interquartile range is quartile 3 minus quartile 1. Again, taking a difference is looking at how spread out the data is. The variance, denoted by sigma squared, is the average of the squared differences from the mean. The standard deviation is just the square root of the variance, and is one of the most common and useful measures of variation. A low standard deviation indicates data that are clustered near the measures of central tendency, whereas high standard deviations indicate data that are spread out from the center. The objective here, when we're looking and collecting data and coming up with the data set, we obviously want our standard deviation to be low. We want our data to be clustered around our mean. If our data is spread out all over the place and we have outliers, which we will talk about, our data is not going to be as valid, and it's not going to be as nice to use to make statistical predictions. So how do we find the variance and standard deviation? There's going to be steps that we are going to follow. We're going to find the mean of the data. We already know how to do that. Then we're going to look at each of our data values in the data set and look at how far away are they from the mean. So we're going to look at the difference between the mean and each data value and square it. Why are we squaring it? Well, because variance is the squared differences from the mean, and then we're looking at the average. So once we do that, we're going to add all the squares of all the differences from the mean, add them all together, and divide by the number of data values. Standard deviation is the square root of the variance. Let's just go through an example that will demonstrate it much clearer. So step number 1, we have to find the mean. So we have to add up 1 plus 2 plus 3 plus 4 plus 5, add those all together, divide by the number of numbers in our data set, which is 5. When we add those all together, we get 15 over 5, which is equal to 3. That is our mean. Now the next step is we're going to look at how far away are each of our data values from the mean, and then we're going to square that difference. Those were the steps above when it said, I'm on step 2 now. I'm going to find the difference between the mean and the data value, and then I'm going to square it. So I'm going to look at 1 minus 3. I'm going to take 2 minus 3. I'm going to take 3 minus 3, and so forth. And now I'm going to square each of these. Be careful if you use your calculator, because if you square a -2 on your calculator, it's going to tell you it's a -4. You must put the -2 in parentheses so that the calculator uses PEMDAS. Same thing here. If you can just remember that whenever you square a number, whether it's positive or negative, you're going to get a positive number. Now I am on, so let me just do these little, this was step 1. Over here, this whole thing is our step 2, and our step 3 says that we're going to add all of the squares of all the differences together and divide by the number of data values. So I'm going to take 4 plus 1 plus 0 plus 1 plus 4 and divide it by 5. Step 3 is going to tell me that that's 10 over 5, and that is 2. I just found the variance. Now let's go on to step number 4. So what step number 4 says is you're going to take the square root, because that will give us the standard deviation. So if I take the square root of the variance, I get the standard deviation. So let's go like this. And the square root of that is 1.41. And that is the standard deviation, which is actually not a bad standard deviation. It's pretty low. Those are the steps we follow. And again, let's just review. The lowest standard deviation indicates the data values are clustered near the mean. Our mean was 3. So our standard deviation of 1.41, well, it's okay. Not great, but it's basically, that's what that's representing. That's the mean. Standard deviation represents how close that the data values are to the mean. Right. Example 2, we're going to do in class 3 also, and 4 actually, which leads us to the video questions. Please write those, or please complete those in your notes.